Hello class, so we have been discussing the difference between expressions and equations and how to translate expressions into words. Today we are going to use that knowledge to build equations and expressions and also learn how to graph them as well. The title of today's lesson is Working with Expressions and Equations, Part 1. This will be a 2-day lesson, today and tomorrow, and that is our standard that we are covering. Today's learning target is I will be able to create algebraic expressions and equations to model situation. The first question. Alex writes an expression that shows the difference between k and 8. What was the expression? So we must first understand that an expression does not have an equal sign. We talked about that. We must know what the word difference means. Difference means subtraction. So we are looking for a subtraction problem, and we are looking for k minus 8. Number 2, which of the following expressions has a coefficient of 7 and a constant of 4? So what are we looking for? Well, what is a coefficient? A coefficient is a number that is being multiplied by a variable. Now that variable is an unknown number, usually represented by a letter. Constant is a number all by itself. So we are looking for a number that's being multiplied by the variable next to 7 and a number by itself, 4. So we are looking for B, 7x plus 4. Are there any questions? Awesome. All right, today's connection. So we've talked about expressions. Now let's talk about Miss Palmer and her age. Let's say Miss Palmer is 28 years old. I want you guys to write an expression. How old will Miss Palmer be in 4 years? How old will she be in a decade? How old was she 5 years ago? And how old was she 11 years ago? So if Miss Palmer is 28 years old and we add 4 years, she will be 32 years old. B, how old will she be in a decade? Well, we must know that a decade is 10 years. 28 plus 10 equals 38. So she'll be 38 years old in a decade. How old was she 5 years ago? So we must subtract 28 minus 5. 5 years ago, she was 23 years old. How old was she 11 years ago? Again, we're subtracting because that's the past. 28 minus 11 equals 17. So these are expressions, but we can get an answer to solve. So these are equations. Now, let's take our knowledge of expressions and let's add a variable. So we don't know how old Mr. Haskin is. So we're going to say that he is X years old, an unknown number, X. And we're going to figure out how old he is 4 years from now, 10 years from now, and 5 years ago, and 8 years ago. So we're going to use X as his age. So for 4 years from now, we want to know in the future. So we're going to add 4 years to X, X plus 4. 10 years from now, we're adding 10 to X 5 years ago, so we're talking about the past. So we're subtracting X minus 5. 8 years ago, X minus 8. Now let's say that we knew his age. Let's say that we knew that Mr. Haskins X equals 29. So we can take the X out and substitute the 29 in. So we get 29 plus 4. So Mr. Haskins will be 33 years old in 4 years from now. 10 years from now, if we do that, substitute X for 29, we get 39 years old. 5 years ago, if we take the X out, substitute 29, we get 29 minus 5. which equals 24 years old 5 years ago. 8 years ago, we get 29 minus 8, which equals 21. All right. So now let's talk about our mini lesson. So we're going to look at Ben's family corn maze. During the fall, Ben's family operates a corn maze on their farm. They charge $8 per visitor, and we're going to use the variable N to represent the number of visitors, and we want to come up with an expression to show the total amount of money collected. Now remember, expressions do not have equal signs, so let's take what we know. We know that they charge $8 per visitors, so our expression is going to be 8N, 8 times the number of visitors. Are there any questions on that? Awesome. Okay, now let's say the family wanted to estimate how much money they might receive from maze visitors on any given day. They decided to make a table that would display this amount for several different numbers of visitors for one day. So I've got a table. Let's take our expression that we just created, 8N, and let's talk about the number of visitors. So 8N, if we have no visitors, how much money is being collected? Well, 8 times 0 equals 0. So they're not collecting any money, which makes sense. All right. What if 5 visitors come to the corn maze? So we take N out, substitute it with 5. 8 times 5 is 40. So they are collecting $40 for 5 visitors. I want you and your group to go ahead and try to finish the table, and then we're going to talk about how to graph this table in just a second. Okay, now let's talk about if we have 10 visitors, how much money did they collect? So we have 8 times 10, which is $80. If they have 15 visitors, we have $120 that they collected. 20 visitors, 8 times 20 gives us $160. 8 times 25 is $200. So as you can see, the more people that come to their corn maze, the more money the family gets. Now, remember, an equation is when we set an expression equal to something. For Ben's farm, the total amount of money we're going to represent with T also is a variable. It depends on the number of visitors for any given day. We call the total amount of money collected the dependent variable, and the number of visitors the independent variable. So the equation for the amount of money collected is 8N equal to T. The money that the family collects depends on the number of visitors that come to their corn maze. All right, does that make sense? All right, let's graph these. So if I take my table and I graph, so if we have on the y-axis the amount of money collected, and on the x-axis the number of visitors in. So we're going to graph the number of visitors and the total amount collected. So let's look at our table, and we see that if nobody comes, so we have 0 visitors, the family makes no money. All right, let's say 5 visitors come, and we found that 5 times 8 gives us 40. 10 visitors come, 10 times 8 gave us 80. So I want you to go ahead and you and your group to graph the lines of the number of visitors that correspond to the amount of money that they collected. So as we do this,